Hello class, it's Mr. Cowboy again here, and I'm here with the fourth lesson for chapter 6, dealing specifically with parallel and perpendicular lines. So we're just going to focus on that topic for today and how it relates to slopes. So when we're dealing with parallel and perpendicular lines, first of all, you've probably, of the two words that you have up there for parallel and perpendicular, okay, you've probably heard of parallel lines, and parallel lines are simply lines that will never ever meet. Okay, so basically, again, if you have two sets of lines and they will never ever touch, those would be examples of parallel lines. So up until now, that's probably what you know about them. And then we'll talk about what perpendicular lines are. All right, so what we're going to do for today is not only talk about what parallel and perpendicular lines are, but we're going to see something specific when it comes to their slopes. So what you need to know about parallel lines, like I said before, since they never touch, okay, not only are they going in the same direction, okay, but they will always have the same slope. So if you have, for example, two lines like so, okay, you notice that we have two lines, even just by looking at them, you can tell that they will never touch. However, what indicates that they will not touch, first of all, the two arrows, you notice there's arrows in the middle. Anytime you see these arrows in the middle here, these ones over here, okay, this will indicate that what you have there in the diagram are two sets of lines that will never ever touch. Okay, so I just wanted to clarify what these arrows are compared to these ones. These ones over here just indicate the direction that it goes in both ways there. Now, as I said before, anytime you have parallel lines and you have equations of parallel lines, they will always have the exact same slope. So for this diagram here, you notice that we have y equals x plus 2 that represents the top line, and then y equals x that represents the bottom line. Okay, each one of these here have the same slope because they both have a slope of 1. So as long as they have the same number, including its sign, that tells you that what you have there are parallel lines. Okay, now that part is relatively easy to remember. It's perpendicular lines that might be a little bit tricky at first. Now, what you need to know about perpendicular lines specifically is that they are lines that meet at one point, specifically at a 90-degree angle. So that's the thing that's specific about perpendicular lines, is that they will meet just specifically at a right or 90-degree angle. And what we're going to learn for today, and this is the part that's going to be tricky at first, is that when you have perpendicular lines, okay, their slopes will be called negative reciprocals, or they are negative reciprocals of each other. Now, that's kind of a tongue twister of a word there or term, but basically what's going to happen here is that if you have the equation of one line, okay, you can figure out what slope is of the other line simply by figuring out what the negative reciprocal is. And I'm going to go through the steps behind that. Okay, so for example, on your sheet there, okay, let's just say you have you have a slope of 2. The negative reciprocal of 2 will be negative a half. All right. So I'm going to talk about why that's the case there in the other slide here. So let's go to our whiteboard here. So let's just say we have a slope of 2. Okay, and basically what a negative reciprocal is, it involves two different steps that converts this number into a negative reciprocal. Now, if you think about the word itself, negative and reciprocal, okay, those two represent the two different steps that you need to do to a slope. So what negative really refers to is taking the number that is given to you, okay, which is the slope, and just making it the opposite sign. So step number 1 over here, what's going to happen to this 2 over here? Okay, it's going to become negative 2. All right, so that's step number 1. Now, what reciprocal refers to is taking this number, okay, and basically flipping it, okay? So for example, when you have a whole number, okay, there's an invisible 1 located right below it, okay? So I'm just writing it like that because I don't have a fraction function to deal with here. So basically what's going to happen over here is that this negative 2 is going to swap itself with the denominator, and that will now become negative 1 over 2. All right, so just to show you again what's happened here, so we take a slope of 2, okay, change it to the opposite sign, okay, make it negative 2, and then just flip the numerator and the denominator there. So that's why when you have a slope of 2, the negative reciprocal of that would be negative a half, okay? And another example here, let's just make it a little bit tricky over here. If I had something like, let's just say negative 3. okay? And I want to change that to a negative reciprocal, okay? So as I said before, when you're thinking about the negative part, what you have to do in that step there is change it to the opposite sign. So if you take the negative 3, for example, okay, and you just have to change the sign, notice that will become a 3, all right? Now, just like the previous example over here, this 3, okay, really has an invisible 1 underneath it. So this is really 3 over 1. So to take the reciprocal of that, all you're doing here is, quote, flipping the 3, and that's going to give us now a brand new slope here of 1 over 3. Okay, so that would be the negative reciprocal of negative 3. Okay, now just to toss up another example over here, let's throw in the fraction over here. So let's pick, I don't know, 1 over 4. Okay, we're going to do this exact same way over here. So let's just say we had 1 over 4 here, and we change it to the opposite sign. Okay, so from 1 over 4 over here, this would just become negative 1 over 4. Okay, so that would be step number 1. And then after you change the sign, because this was a positive, now it's become a negative. All we did here was change the opposite sign. All we would have to do is to flip or swap the negative 1 and the 4. Okay, so what we would have here for the last part over here, using arrows in the diagrams over here, this would now become just negative 4. Okay, so like I said, once we see more examples just like it, okay, and you get more practice with it, you will see that some of you could probably do this right away. But again, when in doubt, go through the two separate steps for that, and then you will get the answer that you're looking for. All right. Okay, so let's get right to it here, and let's take a look at parallel and perpendicular lines again. So like I said, when we're looking at parallel and perpendicular lines, so when we're looking at parallel and perpendicular lines here, just to finish off the example we just did. Okay, so for the diagram over here, you notice that what we have here, one line has a slope of negative 2, okay, and the other line has a slope of 1/2. So you're probably wondering, well, how did we go from negative 2 to 1/2? Well, if you take negative 2, for example, okay, remember the two steps that we have to do here, okay, is to uh, change the sign, okay, and flip the number. Okay, you can actually do it in a different order as well. You can flip the number and change the sign. Okay, whatever you do, okay, just make sure you're staying consistent. Now notice that for this one over here, I flipped the number first, okay, because again, you can. So when you take the negative 2, for example, okay, and you flip it, that becomes negative 1 over 2. All right, and then after that, you change the sign. So that's how it becomes 1 over 2. All right. Now, if you decide to change the sign first and then flip the number, that works as well. Just remember, if you take a look at the two numbers here, all you're doing here again is changing the sign and then switching the numerator and denominator. Okay, that's it. Now, as you go through the problems in your review, okay, you'll get a lot of practice on that. Just make sure that for every single one that you're doing, that you're checking to see if you're on the right track there. All right, let's see some examples here over here. So let's start off with the first one. So it says here, a line has an equation of y equals 3x minus 7. Okay, so we have a line that's given to us already. And what we want to do here is to simply come up with the slopes of another line that is parallel to this one, okay, and perpendicular to this one. All right, so let's do this step by step. Now remember, when we're dealing with parallel lines, okay, slopes have to be the same. Okay, so a line that is parallel to y equals 3x minus 7 will have a slope of 3. Okay, and that's just because when you have lines that are parallel, they'll always have the same slope. All right, now for a line that is perpendicular, okay, the slope must be a negative reciprocal. So if we have a slope of 3, we have to take that 3 and find the negative reciprocal of that. And remember, the way we do that again is to flip the number or swap the numerator and denominator, okay, and then change the sign. Okay, so for example, when you take 3, okay, and you switch the numerator and denominator, you'll get a fraction of 1 over 3. Okay, so that would be step number 1. Okay, and in step number 2, you would change the sign to make it a negative 1 over 3. So a line that is perpendicular to 3x minus 7 will have a negative reciprocal slope which will be -1/3. Okay, so I want you to take a look at the next question. Just pause this video for a moment, and I want you to do this next question over here. All right, so it says here, a line has an equation y equals -1/4x plus 2. And what we want to do here is determine the slope of a line that is parallel to it and perpendicular to it. Now remember that the first thing you need to do, first of all, for any equation that deals with parallel and perpendicular lines, always identify what the slope is. And remember that the slope is the number that's attached to the x. Okay, so since it has the same slope, a line parallel to this line here will have a slope of -1/4. Okay. Now remember, when it comes to perpendicular lines, the slopes must be negative reciprocals. So what you have to do here is take the -1/4, okay, and go through the steps, flipping the number and then changing the sign. So when you take the -1/4 and then you switch the numerator and the denominator, okay, that's going to give you -4. And then when you change it to the opposite sign, that will give me a 4 there. All right. So remember, again, as long as you follow these two steps, okay, it doesn't even matter which order you do it in, you'll always get a number that that's going to be opposite in sign as well as flipped around. Okay, so just remember that as you're going through the practice questions. All right, let's take it up a notch here. Now it's going to get a little bit tricky because we've got to do a lot of reading. So again, this chapter the title of this entire chapter itself is Analyzing Linear Relationships. And this is one of those questions where you actually have to read the question very carefully to see exactly what you need to do and how you're going to come up with the correct answer. So it says here, a line has equation y equals -4x plus 3. And what we want to do here is to find the equation of another line that is parallel to this one and has a y-intercept of 5. Okay. Now take a moment to read that question again, because there's a lot of key words in there that's going to help us determine how we're going to approach this kind of question. All right. Now, typically I ask students, what is the one word that sticks out in this problem that's going to help us answer this question here? And quite often they give the right answer, which in this case here is the word parallel. All right. So I'm just going to underline it in blue here. Now, the reason why that's important, because as long as you see that part, okay, the very first step is very crucial to understanding what we need to do in the steps after that. So step number 1 here, okay, as I said before, since the line is parallel, the line must have the same slope, okay? So when you take a look at this, at the equation that's given to us, it tells us here that the slope here is -4. So the slope of the brand new line is going to be -4. All right, so that's step number 1. Now, step number 2 over here, it gives us a y-intercept of 5. Now, remember that the y-intercept, when you have the equation in the form y equals mx plus b, okay, is always going to be the b. So all I'm going to do here is replace the -4 in for the m, and this 5 is going to go in for the b. So an equation that is parallel to y equals -4x plus 3, okay, and has a y-intercept of 5 is going to be y equals -4x plus 5, okay? So notice again, it's very important that you read the question very carefully, because once more and more questions that we're going to look at later in this chapter come along, okay, it's very important that you break the question down and see what important pieces of information are out there. Notice that in this question here, as long as you break down the different parts of the question, you'll be able to come up with the answer just based on the information that you see in the question. Notice that there was no algebra behind it. It was just being able to read the question very carefully and seeing where the numbers go into the equation. Now, again, anytime a question asks you for the equation of a line, okay, the first thing that you must always write is y equals mx plus b. And you're going to see that in this last example as well. So it says here, a line has the equation y equals 3x minus 6. So it says, what is the equation of a perpendicular line that has a y-intercept of -9? So the key word in this question here is the word perpendicular. All right. So once you establish that, what you could do is to brainstorm, okay, what that means. Now remember that when you have lines that are perpendicular, okay, you will have slopes that are negative reciprocals of each other. So if you take a look at the original question, what we have here is a slope of 3. So what we need to do that to that 3 is to find what the negative reciprocal of that is. And remember, the way we do that is to flip the number, meaning we swap the numerator and the denominator, okay, and we change the sign to the opposite sign. So if I take the 3 and I, quote, flip it, we get a fraction there of 1 over 3, and then we change the positive to a negative, so the negative reciprocal of 3 will be negative 1 over 3. Now, this next step is very crucial because quite often people will get to this step here and not know what to do. So now that we found the negative reciprocal, okay, we no longer have to worry about this 3. So when we come up with the equation of our brand new line, we're now going to replace the m with the negative reciprocal slope here, which in this case here is the negative 1 over 3. So right now we have our m. So when you read the rest of the question, you'll notice what you have here. It also gives us the y-intercept of negative 9. So that's going to go in for the b. So when you put the numbers in for the m and the b respectively, we get y equals negative 1 over 3x plus negative 9. And just as a reminder, when you have a positive and negative together, always simplify that by changing it into a negative. All right. So again, just to recap this one, okay, this line here, we had an equation of y equals 3x minus 6, and we had to find the equation of another line that was perpendicular to it, but had a y-intercept of negative 9. Okay, so notice again, anytime you hear the word perpendicular, you take the slope as given to you, and you find the negative reciprocal of that. Now, you take that slope, the negative reciprocal, and then you place it into the m for y equals mx plus b. So once you find the negative reciprocal, that's the slope you're going to use to come up with your brand new equation. Okay, and the y-intercept is always going to be b. All right, so that wraps up the lesson on parallel and perpendicular lines, and I will see you in the next lesson.